U.S. Department for Energy reported that 51.7% of homes were heated by natural gas. So we're thinking that P equals 0.517. The reason I'm using P instead of mu is this is a proportion or percent. A random sample of 221 homes, so N equals 221, found that 127 were heated by natural gas, so X equals 127. Does the evidence support the claim that alpha equals 0.05? So if this is my null, my alternative is that P does not equal 0.517. So it's the opposing view. So we have equals and then not equals is the last one. Now for the p-value, we'll go to StatCrunch, and this time, since we're dealing with proportions or percents, we're going to use StatCrunch, and we're going to use proportion stats instead of t-stats. Since we have a proportion with proportion stats. One sample with summary, the number of successes, 127, the number of observations, let's see, so we have 127, 221, and 0.517. So 127, 221, and it's equal to 0.517 and not equal to 0.517, and then compute. And we have our z-stat, which is 1.715, and our p-value, which is 0.0863. So the p-value is 0.0863. The alpha was 0.05. So if the p-value is low, the null must go. If the p-value is high, the null must fly. And what determines if it's high or low is your significance level, your alpha. So since 0.0863 is higher than 0.05, that's high. So if the p-value is high, the null must fly, which means you're not going to reject it. And so there is not sufficient evidence to conclude that it is not 51.7%. So the null said that it was equal to 0.517, and we did not reject this. So we cannot accept, or there is not, if we're failing to reject this one, that means we're not using the alternative. So there is not sufficient evidence to conclude that it's not 51.7%, because not 51.7% is the alternative, and there's not sufficient evidence. Now, the sample only takes place in one state, so this is the answer, it would not be representative for the entire country. For number 5, driver error can be listed as the cause of approximately 54% of all fatal auto accidents, so 0.5 P equals 0.54, according to the American Automobile Association. 30 randomly, so N equals 30. It is determined that 12 of them were caused by driver error. Assume alpha is 0.05. So P equals 0.54, P is not equal to 0.54. So this is your null and this is your alternative. So equal to 0.54 and not equal to 0.54. And the p-value, so again we're using proportions. So it's going to be proportion stats, one sample with summary. The number of successes, 127, now the number of successes is 12 out of 30, and our population proportion is 0.54. So 12 out of 30, and we're doing a hypothesis test, and we're having it equal to 0.54 and not equal to 0.54, and then compute. So our z-stat is negative 1.54, and our p-value is 0.1239. So the p-value is 0.1239, and our alpha was 0.05. So if the p-value is high, the null must fly. 0.12 is larger than 0.05, so we are not going to reject the null. So there is not sufficient evidence to conclude that it's not 54. And is the AAA percentage accurate? It appears to be accurate because AAA is the one that said that it is 0.54. And if we're not rejecting the null, then it seems to be that they're accurate. So what's happening here is that AAA is saying that it is 0.54. The alternative or opposing view is saying that it's not 0.54. So here is your population proportion, 0.54, and your p prime, which is 12 over 30, is your sample proportion. And so you're getting that it's 0.40, right? This gives you 0.40. And now 0.40 does look like it's lower, 40% or 0.40. So 40% does look like it's lower, so maybe there's evidence to conclude that it's not equal to 0.54. But when you found out the p-value in the test statistic, you get negative 1.54, which corresponds to an area of, well, both these areas combined, because it's a two-tailed test. Both the areas combined correspond to an area of 0.1239, which is showing that it is just due to sampling variability that you got such a low result of 40%. Nothing new is happening here. There's not evidence to suggest that the alternative is correct. It's just sampling variability. So 40% is very close. It might not seem close to other people, might not seem close to 54, but it is close in the sense that what the p-value means is if H0 is true, then there is a 12.39% chance of getting 40% or more extreme. Now, if it's a very, which is not very unlikely, that's kind of likely, right? You have a 12% chance of getting 0.40, as opposed to in other problems, if it was really low, like 0.0001, right? That's very unlikely, and that's when you would reject the null and accept or favor the alternative. But here you have a 12% chance. If you did this sample again with another 30, there's a 12% chance of getting 40% or more extreme. So that is why we do not reject the null, and there's not evidence to suggest that the alternative is correct.